Good morning, friends. This is Somnath Chattopadhyaya from the Department of Mechanical Engineering, Indian Institute of Technology, Indian School of Mines, Dhanbad. Today our topic of discussion will be extrusion, which is a very popular process and extensively applied in the industry. So right from the title slide we can see the typical extruder with a feeding hopper and with this feeding screw, which is responsible for taking all those materials and pushing those things against a shaping die, and from there itself the extruded the product will be coming out of it. So there are some heaters because it is a typical hot extrusion. It can be done for plastic, it can be done for rubber, it can be done for metals. So all those things can be put together and the feeders will just push all those plasticized material in heated condition against the die, and different kind of products like say hollow cross sections will be produced. If we can use a mandrel there in between the die inappropriately aligned, then we can have tubes and pipes, and we can have sheets, we can have sheet and film, we can have structural parts and all sorts of things. So depending on the die, huge amount of extensive materials. Only limitation is that it has to be longitudinally symmetric. It has to be symmetric longitudinally. So variable shapes cannot be done in terms of longitudinal one, and if it is the symmetric one cross section wise, then definitely we can do it in a easy way, and that is why it is popular. It is invented in near about say 1800 in the time of industrial revolution in UK, and then some modifications like use of dummy block has been discovered, innovated by the German engineers in near about 1890. So what is extrusion? Extrusion is a compressive or compression process in which the work metal is forced. Force is done, drawing, pulling. For extrusion, pushing. The work material is forced to flow because that fluidity has to be ensured. As it is a ductile material, it has some flow, and it has been forced to flow through a die that is giving up the typical cross section opening to produce a desired cross sectional shape. So whatever desired, that will be implemented in the intricate parts of the die, and that die has to be designed in that very way, manufactured that very way, and die will deliver in that very way. And the process can be just like squeezing, whatever every day we do while washing our hands and face and brushing our teeth. So we just squeeze our toothpaste out of a toothpaste tube. So similarly, we squeeze it against that die, and that way the product is produced. So extrusion, as we have said already, extrusion dates from around 1800. What is the advantage? There are several. First, variety of shapes. We have sheets, we have hollow shapes, we have solid shapes, we have rectangular shapes, structural shapes, all those things can be possible. And mostly it is done by hot extrusion, metallic extrusions and other things are hot extrusion, but in case of rubber and other places, some advantages of cold extrusions are also there. And cold extrusions are having other advantages. And grain structure and strain properties are enhanced very specifically in cold and warm, not specifically for hot one, because every time recrystallization and no strain hardening effect will be in hot extrusion, but there will be in case of cold extrusion. Cold extrusion will produce better surfaces, less uncertainties in terms of the dimensions, and surface finish will be much better. But everything cannot be cold extruded, so wherever it is done, it can come out with fantastic product. Near net shape or net shape manufacturing process is possible. So fairly close tolerances, whatever we have told that possible, especially for cold extrusions, because the dimensional uncertainties in any cold forming process is favorable. So dimensionally very reliable, but not that reliable in terms of hot extrusion. And in some extrusion operations, little or no wasted material. In mostly, we don't waste the material. So immediately, whatever material is utilized, it is formed and giving appropriate shape. Not like machining, where a lot of chips will come out of it, and it has to be recycled and waste material, and it becomes a really costly process, because a lot of waste will be there. In case of extrusion, the beauty is that minimum possibility of waste or no waste at all in many cases. But some limitation is that of the extrusion process is that cross section of the extruded part must be uniform. If it is not uniform, it cannot be extruded, because extrudation we do for a long length items, and if it is not uniform, it cannot be produced. But if it is uniform, productivity is terrific. Long products can be done, and according to that they can cut acrosses, so productivity is not a problem. We can go for huge quantities, only that uniformity throughout its length has to be there. Otherwise, it is not a typical case of extrusion process. So it is an industrial process invented in 1800 in England during the very important event was taking place, Industrial Revolution, and that has changed the shape of the world. When that country was leading in the world in technological innovations, and they're ruling the world, and then the innovations are also taking place. Their innovations enable the Britishers to rule the world in terms of technological aspects. And the invention consists of the first hydraulic press for extruding lead pipes. The advantage of hydraulic press is that the biggest advantage that it can give stepless, non-jerky, smooth and blunt forces. Not very fast, but smooth, stepless, non-jerky. And this is very much required in extrusion. It has to be uniform and stepless forces, sometimes not easily can be done by electric drives. So that is why hydraulic is best suited to press, and whenever the pressure is exorbitantly high. So at that point of time, the engineers have designed the hydraulic press in order to drive the ram, and that ram is responsible for pushing those materials against those dies, and according to that, those uniform cross-section, long-length product will be produced. Another important innovation took place in the then Germany. In 1890, Germany was geared up for their late industrial revolution entry in the world. And that point of time, in the first horizontal extrusion process was built for extruding materials with higher melting points than lead. Lead has a lower melting point, so extrusion becomes easy. But whenever melting point is higher than the material like lead, it is a very challenging one. Huge amount of forces will be required. The machines has to be very robust, rugged and rigid. And some kind of innovations and other things are there, and that has the German engineers have innovated. That is dummy block. Dummy block is a game changer in terms of extrusion, because extrusion, whenever higher temperature is required in hot extrusion, there is always a possibility of oxide formation, and this oxide formation will be there in the vicinity in the container of the extruder because of the contamination of the oxygen. And if the oxide comes as a product in terms of the layer, integrity of the product will be compromised, and because of the oxides and other things, the frictional force will be more, so that it will not be efficient. Many forces are there, and the entire things becomes problematic so far as productivity is concerned, and also quality, because the surface and other things, the oxide materials and all those scales will be extruded in the form of those skin. So people have come out of a dummy block. Dummy block is slightly lower than the plunger, so they will just instrumental in pushing all those core materials which are not oxidized, because they are not in the periphery, and that way the problem of the scale formations or oxides and other things in the periphery, circumferential area is less, specifically for the aluminum extrusion, and as they are not in contact in terms of the movement against the die, the frictional force is less, so it is smooth and efficient. And we can find it out so many cross sections we can produce. One is a full hollow section and semi hollow section. So we can see that velocity, with some velocity and force, the ram is pushing the plunger into, and whenever there is a mandrel, and that is essentially concentric way placement against those die, and the raw material is pushed and circumferentially along the circumference of the mandrel, they will go there, and then product will be there, and thus the hollow sections will be produced. The hollow sections may be circular, it is in case of pipe, may be rectangular or oval in case of tube, or for tube also have these hollow circular section. It is possible, and not only that, even we can go for the semi-hollow sections, whatever it is given in these figure. Semi-hollow sections also can be produced by the extrusion process, and that is a game changer. You can produce all those angles and channels in a typical fashion, depending on the die and depending on the setting of the mandrel. So what is the use of the dummy block? A dummy block is one of the problems in direct extrusion, and this is the significant friction that exists, and it is reducing that work surfaces, walls, because it is pushing only the core material, and the friction is between those layers in the core. So it is not friction against the wall of the container. So it becomes very smooth. And this friction, if it is not, dummy block is not used because of the friction against the wall, it becomes a hazardous. The ram force required lot more, specifically in the direct extrusion. And in hot extrusion, the friction problem is aggravated by the pressure of an oxide, because whenever hot extrusion is there, the possibility of the circumferential material at the circumference has the possibility of the oxide formations, and these oxide layers and other things on the surface of the billet, and they are the culprit of increasing the friction, and the entire process becomes not very smooth. So dummy solves this kind of problem. So the oxide layer can cause defects. If the oxide layers come out after the die, it is a defective one. To address this problem, the dummy block is very intelligently, it is slightly smaller, very small, simple innovation, but very effective, smaller than the billet diameter, so that a narrow ring of work material, mostly the oxide, is left out in the container. So oxide, you are formed, you are the culprit, you stay in the container. We will not use you in the product itself, so that the quality of the product is not jeopardized. Detrimental effect of the oxide formations and their existence in the periphery of this material possibility is diminished. That is why it is slightly smaller, left in the container, leaving the final product free of the oxides. Simple yet terrific, intelligent innovation in order to leave those oxide materials and making all those process of extrusion very smooth and hassle free with better quality. So we can see these things, use of the dummy block. So plunger or the ram is forced, the dummy block slightly lesser in diameter than in the container, and that way it is just pushing the core material. Whatever in the periphery oxides remained in the container itself. So those oxide formation don't come into the periphery of those extruded, and the quality of the extrusion is great. And because there is no friction between the container wall with those oxide layers, as the dummy block is smaller, their process is smooth, less frictional force is required, and productivity is high, smooth and terrific. So this is the picture of the dummy block, and this is the functional advantage of the dummy block. So dummy block is the most critical element, very critical element of the aluminum extrusion process, because aluminum has a strong affinity to form oxides, and specifically at elevated temperature, and the temperature has to be elevated. The reason is that in order to bring plasticity, enough plasticity and flowability so that the product can be extruded. So heating is a necessary evil, but the problem with that, the possibility of the formation of the oxides is always there, very specifically a material like aluminum. So it is a game changer. So if the dummy block is used, and if it is used appropriately with the design, with the lesser than the container diameter, the product quality and efficiency, all those things will enhance to a significant extent. And the dummy will act as a part of the system, and its performance depends on the series of factors. There are many factors. The centering adjustment, dummy block has to be centered appropriately, otherwise it's a problem, because some layer in the top part oxides is coming in, the other part it is not. So its alignment is very important. It should be concentric in terms of the container position. And the temperature and the physical feature and all those things associated with that, and then lubrication also, because how lubricated, how, and regular maintenance. The maintenance, the biggest advantage is that if any kind of time the dummy block is associated with, adhered to all those heated aluminum oxides or those kind of materials, aluminum product, easily one dummy block can be detached and another can be installed. So online maintenance will be there, so that the changeover and other things becomes easy without much problem. If it is that the entire plunger and ram has to be replaced because of the adherence of all those extruded billet material, it will be cumbersome. So dummy block take care of all those things, and immediately if it is detachable one, so modular maintenance can be carried out with some extra dummy block. So while the extrusion process is going on, the other dummy block is getting cleaned, and whenever it is ready, appropriate within very little time, we can change for that. So this also gives some online setup time, and which is very good for just-in-time practices like say SMED, single minute exchange of die. So the die changing times and repair and all those things, and even necessary idle times and other things can be reduced to a great extent with this modular design of those dummy block to be attached with the plunger. And the most important factor is that a container with homogeneous heat balance, because heat balance has to be there, because if it is non-uniformity in the flow of the heat, then the non-integrity of those extruded will be there. So homogeneous balance and other things that dummy block can ensure. Proper heat distribution will be there, and with those measurmental consistency and efficiency and all those things, a win-win situation. That is why it is so very important to have the dummy block, very specifically for the aluminum extrusion is considered. The function of the might seem to be very simple at the first sight. It is very easy, straight, nothing very complicated innovations, but its role is tremendous. The extension of the stem used to press the softened alloy through the die, and easy for the softening one associated with that, and rapidly expand and stop at safe limit under pressure, and only a thin alloy film layer on the inner surface, smaller layer, and all those things are oxide layers are left in the container itself, and detachment associated with the billet for the cleaning action. So whatever we have already told, that the cleaning action, online maintenance without much delay can be done parallelly if we have the number more than one dummy blocks. And not to cause any gas entrapments, because the heat balance and other things are ensuring that the gas are not entrapped, and the liners and all those things of the dummy block and other things will ensure that, and transfer the power of the press in a very smooth way of transfer of the power to the alloy, and high temperatures it is possible, ensuring the heat balance and better quality of the product is possible. So functions to contribute to the solving of the minor press centering problem. So just that centering has to be done appropriately. If it is not done, then there is a possibility of some cases some oxide and some non-uniformity will be there. And to be able to detach and attach rapidly, that we have to do, that is the designer's prerogative, so that the plunger, the ram associated with dummy block attachment, detachment should be very fast and easy. Then the method will be effective. Otherwise, a lot of time will be spent in terms of these cleaning actions. and to continue performing stock until the completion of the production process will be there, and this will enhance the production along with the dummy block. And we can see again once more that the types of extrusions are divided in 4 types. One is direct extrusion, where the product movement extruded to come out of the direction of the ram exerting the pressure. So this is called direct extrusion. And indirect extrusion, the opposite, whenever the extruded product is coming out the direction and the force is given by the ram in the opposite direction, that is called indirect extrusion in the second figure. So the product is extruded is coming in the opposite direction, where the plunger or the ram is forcing all those materials to come out. Then it is the tubular extrusion. Tubular extrusion means that people are using the mandrel concentrically loaded on the punch, and it has a small thin area against the die, and from there in the thin slits only the material in the plasticized form are allowed to escape, and by these escape they will form a hollow construction. This mandrel can be hollow, so hollow cross section will be there. If it is rectangle, then rectangle cross section. If it is oval, then oval. So it is a very good, very typical way of producing high quality hollow surfaces without much hassles. So mandrel is also a great innovation. It is done in the extrusion process, but placement of the mandrel has to be concentric, otherwise the wall thickness will not be uniform in nature. But seamless tube manufacturing, these tubular extrusion process is widely popular all over the world. And the fourth variety is hydrostatic extrusion. That means only the mechanical force is not given by the straightway that the solid plunger is forcing a medium, an agent, that is the fluid, and the fluid is giving the pressure. The advantage is that because of the Bernoulli's law, that it will be uniform. There will be non-uniformity in terms of giving the pressure. So the product will be balanced, and there will be no jerk associated with that, and misalignments and other possibilities not there, as the pressure is coming uniformly from those directions, and the product and alignment and the things will be great. So this is called hydrostatic extrusion. We are using an agent in between the raw material and the plunger, and in order to give a very uniform level of pressure. And then this is the bigger picture. Extruded product is coming, the plunger and the fluid is in between, and ram is pressurizing the fluid, and fluid is pressurizing the raw material, and raw material against the die, it is coming out of it. So this is the just and differentiate with a bigger picture with the difference between the solid cross sections where no mandrels are there, and when mandrels are there, then we can have hollow section. This is the utility of the mandrel. If there is no mandrel, solid mandrel, the periphery against the die, the thin sections will be there, and hollow sections will come out of it. So mandrel's role in order to give those kind of hollow sections associated with that. Next, this is a typical pressure, ram pressure is giving, and the length is the remaining billet length that is necessary in order to calculate all those problems related to determining the pressure. The die is shown, D0 is DO is original diameter and DF is the final diameter, and it is pressing against the die, and on those ram pressure itself, the product extruded part is coming with a reduced diameter, that is D suffix F, that is the final diameter. So this is the typical diagram of the extrusions and how the pressures are applied in order to get this process done. So this is the discussions of the extrusion process and explanations related to the classifications of different extrusions and diagrammatic representations of those process. Thank you very much for your patient hearing to this very important topic of extrusions with all its varieties and sketches.